Hello and welcome. Today we'll be going through the OptiAssist Simcenter3D tutorials. This is the Rdm tutorial 1, Reinforcement Development for a Bracket. Here I've already got the model loaded up. Therefore the first thing we shall do is put it through a single analysis. Once that is run, we can click No and close all the windows before taking a look at what's actually happening to the model. Double click on Structural. I want to look at its displacement. Once you're happy with that, we'll click Return to Home and begin the optimization. Under the OptiAssist ribbon, we'll click Rdm Optimization, which will bring up the 6-tabbed window. For the first tab, the subcase, we will select the load case static load and click Next. And then for the design rule, if we click on New, we open up the RDM set definition box. Under the RDM creation method, we change it from existing to projection and displayed to selected. Under select elements, we will keep the drop down to be related to elements before selecting all inner parts of the model. Once you have done that, we will change the projection direction to Y. Target mesh size will be 1.5. And under the creation coordinate system, we'll change the inferred to dynamic, which will automatically pick up the coordinate system of the model. Under the material selection, we'll keep it to local material, with the material being aluminium 6061. Once you're happy with that, we'll click Create Mesh, which has now created the mesh ready for the optimization. We click Finish, and then Next. We come to the Manufacturing Constraints tab, where we change the first one to planar, with the points dialog being already picked out from the coordinate system, and we want the specified vector to be the global Y direction. We then want to change the second manufacturing constraint to extrusion. We want it to be in the Z vector. Under the min size control, we'll use the drop down to change the min size before changing the min size box to 3. We then click Next, and under the goal tab, we'll change the goal type to maximize stiffness, with the mass fraction being 20% or 0.2. Remember to select the subcase and then click Next. No further constraints are required, so again we click Next. And under the settings, we then change the design cycles from 15 to 50. We'll click OK, and the model is now ready for optimization. Under the OptiAssist ribbon, we'll click Solve, and the optimization will begin to run. Once that is finished running, we can close down the window and check the design history. So here we can see the design objective, in this case. The mass increased with the addition of the reinforcement before decreasing and then leveling out through the optimization. We check the constraint violation. This also supports that statement, so we know the optimization has worked. If we go over to RDM plot, reload the results, cycle 20 and plot, we can see the new RDM that has been created for the model. If we want to take a look at the smooth STL, we can click on Export Smooth STL, save the file, and click Close. This confirms that your smooth STL has been exported. We can then close this, and opening the original part and then importing that STL file, click OK. we can see what that would look like with the original part. Once you are happy with that, we can close that down. And from the results, go over to the OptiAssist tab, update model from results, load the results, latest cycle, OK, yes. And here we see the new RDM which has been created for the model. This concludes the tutorial.